Welcome back, dear children. Now our next topic is the differences between mass and weight. Okay, so from lower classes onwards you are learning about mass and weight. What is mass? Mass is the amount of matter contained in a body. How much matter is there? That is known as mass. Then what about weight? Weight is the force with which Earth attracts a body towards its center, isn't it? So, when you are considering mass, what is an object made up of? The amount of matter contained in a body is known as mass, but weight is the force exerted on a body by an object, that is called weight. So, when we are considering our weight on Earth, it is the force exerted by Earth on our body. But when we are considering our weight on Moon, it will be the force exerted by Moon on our body. That means value of weight will vary from place to place, but in the case of mass it is a constant. But there is an exemption that we learned in the beginning, isn't it? If a body is moving with a greater speed, then mass can change, else mass remains as a constant. When we are considering the mass of a body on Earth or in any other planet, it remains same. But the weight will be different because weight is the gravitational force exerted by an object on the body. So, the weight will be different in different planets. Okay, then the next thing is, what about the unit for mass? Mass is measured in kilogram. SI unit of mass is kilogram, but when we are considering weight, its SI unit is Newton. Why? Because weight is actually a force. Then mass is measured using a physical balance or a beam balance, whereas weight is measured using a spring balance. So these are the main differences between mass and weight. So once again, the amount of matter contained in a body can be called as mass, whereas the force exerted, gravitational force exerted on a body can be considered as weight. Mass is measured using a physical balance, weight using a spring balance. Mass is a constant, whereas weight is not a constant. SI unit for mass is kilogram. For weight, it is Newton. Now, what is the CGS unit for mass? SI unit is kilogram and CGS unit is gram. But when you are considering weight, its SI unit is Newton. And do you know what is the CGS unit? CGS unit is dyne. Okay. So please remember this name. CGS unit of force or weight is dyne. Now, what is the relation connecting SI and CGS units of weight? 1 Newton is equal to 10 raised to 5 dyne. Okay, so this also you have to keep in mind. 1 Newton is equal to 10 raised to 5 dyne. So these are the SI and CGS units. Now we have one more set of units. What is that? Gravitational units, isn't it? So do you remember which are the gravitational units? kgf and gf. Kilogram force and gram force are known as the gravitational units of force. Now 1 kgf is actually equal to 9.8 Newton and 1 gram force is equal to 980 dyne. Okay, 1 kgf is equal to 9.8 Newton and 1 gram force is equal to 980 dyne. And we have the definition for kgf. 1 kgf is the force which acts on a body of mass 1 kilogram, and 1 gram force is the force due to gravity which acts on a body of mass 1 gram. Okay, so is it clear? We were discussing about the terms mass and weight. You should know the differences between mass and weight. Then after that, SI unit for weight is Newton, whereas CGS unit is dyne. 1 Newton is equal to 10 raised to 5 dyne. Again, we have the gravitational units, which are they? kgf and gf. Kilogram force, 1 kgf is equal to 9.8 Newton and 1 gram force is equal to 980 time. Okay, so with this we completed the topic. Now we will be doing the numericals, and before that children, it's a little bit big topic, so I don't want you to write the lecture note. What I need is write the answers of all the questions given at the back. That is, you can take page number 79, exercise 3E. Nearly 22 questions are there. For 4 or 5 questions or some few questions, they have given the answers. So don't copy those questions. All the other question answers should be there in your notebook. And I don't want you to write the questions also. Read the question, find the answer and write the answer. Okay. So exercise 3E, all the question answers except whose answers are given here. That should be there in your notebook. And now we will move to the numericals. So we don't want to do all the numericals. The numericals with the change in gravity is excluded from the syllabus. So we have to do only the first 8 questions. Okay, simple questions we have to do. So shall we move to that? Okay, first question. It is given in page number 80. You can write the heading as numericals. First one. The force of attraction between two bodies at a certain separation is 10 Newton. What will be the force of attraction between them if the separation is reduced to half? Okay. So here it is a comparison, isn't it? They didn't ask us to get the value. So we have a comparison. And do you remember what you have to do if it is a comparison? You have to divide, isn't it? So what is our equation? Our standard equation is F is equal to G M1 M2 by R square. This is our standard equation. So this is the first case. Okay, I have taken it as F1. So first we are considering the standard form. We are having two bodies M1 and M2. Two bodies of masses M1 and M2 separated by a distance R. So the standard equation is F is equal to G M1 M2 by R square. I have given it as F1, the force between the two. Now what is the second thing given in the question? What happens to the force if the distance becomes half, isn't it? If the separation is reduced to half. So in the second case, let me write the force as F2, and we are considering the same bodies. So M1 and M2 will be as such. G is a constant. And what is the change? What you have to do? R will become R by 2. Okay. First is the standard form. In the second case, the separation is made into half. So R will become R by 2. Now what is the next step? We have to divide, isn't it? F1 by F2 is equal to G M1 M2 by R square into, I am taking the reciprocal since we are having fractions in the numerator and denominator, by G M1 M2. G M1 M2 and G M1 M2 gets cancelled. Then R by 2 whole square is R square by 4. So this R square and this R square gets cancelled. And what are we getting? F1 by F2 is equal to R by 2 it is. R by 2 whole square. So this will become 1 by 4. Cross multiply this. F2 into 1 is F2. This will be equal to 4 into F1. How much is F1 given in your textbook in the question? It is given as 10 Newton. So 4 into 10 which is equal to 40 Newton. So if the separation between the two bodies is made into half, what happens to the force? Force will become 4 times. Okay. So the answer is 40 Newton. Is it clear? Just write the equation, standard form. Write the equation. Then divide it since it is a comparison. Okay. Now we will move to our next question. Question number 2. Okay. Now we will be moving to our question number 2. Write the approximate weight of a body of mass 5 kilogram. Mass of a body is given as 5 kilogram. We need weight. So what is the equation for weight? I think I didn't say that, isn't it? So what is the equation? Weight and force are same. So here weight is produced due to force of gravity. If it was F is equal to ma. Since here the weight is produced due to gravity, equation for weight is mg. Okay. So mg is the equation for weight. Mass is given as 5. They didn't give the value for g. If it is given, you have to take that. Else, to make our calculation simple, you can take it as 10. So 5 into 10. How much is 5 into 10? 50. Since it is weight, Newton. Okay. So, in few questions, they will give the value of g as 9.8. If it is given as 9.8, you have to take it. In this question, since they didn't give any value, we can write it as 10. Okay, you can take it as 10 so that the calculations will be simple. And one more thing is asked there, what assumption have you made here? So, what assumption? We have taken g as 10 meter per second square. That is the assumption which we took. Okay. Now we will move to question number 3. Calculate the weight of a body of mass 10 kilogram in kgf and in Newton, and the value of g is given there. So, mass of the body is given as 10 kilogram, isn't it? Mass is given as 10 kilogram. Then we have the value of g as 9.8 meter per second square. Okay. Then we have to calculate the weight in kgf as well as Newton. So, what is the answer? When you are considering kilogram and kilogram force, both are equivalent. That is, you can note it somewhere, 1 kg is equal to 1 kgf. But 1 kg is when you are considering Newton. Okay. So if you want to convert kilogram into Newton, what you have to do is you have to multiply it with the 10. Okay. 1 kilogram is equal to 1 kilogram force, but when you are considering, if you want to convert it into Newton, what should you do? 1 kilogram force or kilogram is equal to 9.8 Newton. So, there you have to multiply it with 10. But for kilogram and kilogram force, it is same. Okay. Actually, it is not 10. It is 9.8. So, first case, it is asked to find the value of weight in kgf. So, what will be the weight? Weight will be 10 kgf itself. Did you understand? Weight, if you want to calculate weight in kgf, you don't want to do any multiplication. G യുടെ value എടുക്കേണ്ട ആവശ്യമില്ല. What is the mass given there? That will be the weight. kg ഉം kgf ഉം equal ആണ്. But when you need it in Newton, you have to multiply it with 9.8 or 10. In this question, since 9.8 is given, you have to multiply with 9.8 itself. So, question number 2, weight is equal to 10 into 9.8, which is equal to 98 Newton. Okay. So, is it clear? Mass and acceleration due to gravity are given. Mass is 10 kg and g is 9.8 meter per second square. We are asked to calculate weight in kgf and in Newton. If it is in kgf, you can write the same value. But if you want to convert it into Newton, you have to multiply it with the 10. Okay. Now we will be moving to the next question. Question number 4. State the magnitude and direction of the force of gravity Acting on a body of mass 5 kg, take G equal to 9.8. So direct question, isn't it? Here the mass is given as 5 kilogram. G is given as 9.8 meter per second square. We need the magnitude and direction of force of gravity. Force of gravity anengilum, weight anengilum, the equation will be mg. So F is equal to 5 into 9.8. Okay. So if it was 10, you will be getting it as 50. Like, since it is 9.8, how much we will be getting here? It will be equal to 9.8. Yeah, you will be getting it as 490. 98 into 5, 490. Since one decimal is there, 0.0. So 49 Newton. 5 into 10 it will be 50. Since it is 5 into 9.8, 98. If it is 5 into 98 means you will be getting 490. Since one decimal place is there, here I am putting the decimal point. So the answer is 49 Newton. Now question number 5. Weight of a body is 2 Newton. G is given as 10 meter per second square. We are asked to calculate the mass of the body. So how will you calculate the mass? What is our equation? W equal to mg. So m will be W by G. So 2 divided by 10. How much? 0.2. And since it is mass, the unit will be kilogram. So 0.2 kilogram is the answer. Now we will move to question number 6. Okay. Question number 6. The weight of a body on earth is given as 98 Newton, where the acceleration due to gravity is 9.8 meter per second square. Okay. This is given on Earth's surface. Then, what will be its mass and weight on Moon, where acceleration due to gravity is 1.6 meter per second square? So, we have to calculate the mass and weight on Moon. We know the weight on Earth. So, if you get from this equation, if you calculate mass is a constant. So, mass on Earth as well as mass on Moon will be same. So, what you can do? W equal to mg, or we know that m is equal to W by G, isn't it? So, what will be m? Mass will be equal to 98 divided by 9.8. Since a decimal place is coming, multiply the numerator and denominator with 10. So, 980 by 98. How much you will be getting? 10. 980 divided by 98. So, you will be getting it as 10. Mass on Moon and mass on Earth will be same. Karnam, mass won't change. Isn't it? So, we got the mass. Now, what is the next thing? We need the weight on Moon. So, weight on Moon is equal to mass into gravity. So, what about the mass? Mass is 10. And what is the value of G? mg is the equation. Okay. So, what is the value of G in Moon? It is given as 1.6. 10 into 1.6 is 60. Weight I don't know, that is Newton. Okay. So, first with weight on Earth and value of G, we will be calculating the mass. Mass will be same on Earth as well as on Moon. Then using that mass and value of G on Moon, you will be getting the weight on Moon. Now we will move to question number 7. A man weighs 600 Newton on Earth. So, weight on Earth is 600 Newton. What would be his approximate weight on Moon? So, what will be the weight on Moon? No need to calculate mass and all. So, how will you do this? already we know that gravitational force on moon is 1/6 of that on earth, isn't it? So weight on moon will be 1/6 of that on earth. So 600/6, which is equal to 100 Newton. So what is the reason? G on moon will be equal to 1/6 of weight on moon. This also you can write. Weight on moon is equal to 1/6 weight on earth. Okay, this is a relation connecting the two. What is the reason behind this? Because mass is a constant and G, value of G is 1/6 of that on earth. Okay, now we will move to the last question. What is the force of gravity and weight of a block of mass 10.5 kilogram? So if you ask force of gravity or weight, both are same. Force of gravity means the force exerted on a body due to gravitation, due to the earth, isn't it? The force exerted on a body by earth is known as force of gravity. Weight also, it is the force exerted by earth on a body. So both are same. Okay. So our equation will be F is equal to W is equal to mg. How much is the mass given? 10.5 into G is 10. So the answer will be 105 Newton. Okay. So is it clear? So with this we completed this chapter. No need for the rest. Okay, other numericals. We need only till this question. No need to go in detail with the other laws of motion. So children, you don't want to write the lecture note. Instead of that, you have to write the question answers and numericals. Okay. So is it clear? So by next week, I'll be conducting a test of this chapter. Complete the notes and be ready with the topics. Okay. So thank you, children.